Hello everyone, today I will introduce our WECON Servo talk mode. And today's contents are these 4 points. I will first introduce what's the talk mode and then introduce two talk source, internal command input and analog command input. Last, I will introduce some DI and DIDO settings of talk control. Section 1. Introduction to talk mode. Here we have a simple application. It is a reminding system that requires the attention of the paper to remain unchanged during rereading. When the rereading retrieves 100 meters, the motor will move. The motor will stop, and the cutter will move to cut the paper. In the beginning, the radius is small, so our motor will run in a faster speed. And as the radius becomes bigger and bigger, our motor needs to rotate slower and slower in order to make the tension of paper to be unchanged. So in this application, we need to use our servo torque control mode to make the code unchanged. As I said, torque control mode is used in applications that require torque control, such as printing presses, welding machines, saw machines, and unwelding machines. The driver includes two command input modes. First is analog input, and the second is internal torque input. The current of the servo motor has linear relationships with the torque. So the control of the current can realize the control of the torque. And section 2, internal torque command input. For this torque source, we have these 3 important parameters that need to be set. First is servo control mode. Of course, here we need to set it as 3 torque control. And then for P1-7 torque instruction source, we need to, if we want to use internal torque command, here we need to set it as 0. And then we can set the torque instruction value in P1-8. The range is this one. And here are some other parameters. Most are the limit parameters in order to make sure our servo can rotate safe. Here, these parameters P1-9 is the, you can see in our software, this one. It is the source of the speed limit in torque mode. Through we are using torque mode, we also need to set the speed limit in order to make the servo safe, running safe. Here usually we use internal forward and reverse rotation limit. So here we need to set it as 0. And then we need to set the forward rotation speed limit and reverse rotation speed limit in these 2 function code. The default value is 3000 per round limit, 3000 round per minute. And later we need to set the torque limit source. It is P1-14. This one. And also we usually use internal value, and then later set the forward torque limit and the reverse torque limit. The range is 0 to 3000, means 0% to 300%. And last, here I have another important parameters, P1-90. It is the torque saturation timeout time. If we set this value too small, we may get a error 37, abnormal torque saturation. This one. Now I will introduce how this parameter work. When the torque is limited by the set value of these two, and exceed this set time, we can set a time here. Then our servo will report error 37. For example, if here we set it as 2000 ms, and then when the actual torque is bigger than these parameters and keep for 2 seconds, then our servo will get an error. Here, please note it. If we set this value as 0, then it means we ignored error 37. Okay. And here we have a picture about the relationship between input torque instruction, actual torque instruction, and actual motor speed. Here we have three points need to pay attention. First, the larger the actual torque, the faster the acceleration and the deceleration. Look at this relationship. If our servo set torque is bigger than motor feedback torque, the motor will do a acceleration rotating. And if the servo set torque is smaller than the motor feedback torque, our motor will do a deceleration action. Point 2, the torque limit and the speed limit will work at the same time. And last, less torque will maintaining speed. So now let's look at this picture. And in the beginning, system give a small input torque instruction, and our actual tool instruction is the same as our input torque instruction. And now our motor begin to rotate and accelerate until we get this point. The input torque instruction become a bigger value, but because of our positive torque limit, our actual torque can only be achieved this line. So it means our torque limit is working. And in this segment, we can see our acceleration is bigger than the first segment because our actual torque is bigger. And in this point, our motor speed is achieved our internal speed limit. So the speed can't be increased continue, and keep on this limit speed and running. And during this time, we can see the actual torque is small because we only need a small actual torque to keep the speed. And in this point, because our input torque instruction turn like this, so the motor begin to decelerate. Okay, and okay, next, analog torque command input. Our VD2A and VD2B series servo have two analog input channels. AI1 AI1 is analog torque input and AI2 is analog torque limit. This is no varying. We need to connect analog input to analog signal to our servo CN2 terminal. This is pin 2, pin 3, and pin 33. Look at P 5-9 and 5-10. These two analog value 10 voltage, corresponding speed. Let's check in software. Okay, these two value. Because we are using control mode, so we need to set P5-10. It means 10 voltage corresponding the torque value. The default value is 1000. So means if the analog input is 10 voltage, our servo torque will be 100%. And then the range of this setting is 0 to 3000. And for others parameters such as bias and dead zone, zero draft, we can check this picture. A zero draft means when the analog input voltage is 0, the servo drop sample voltage a value relative to the value of the ground. And the bias after zero draft correction, the corresponding analog input voltage when the sample voltage is 0. So for example, we may need multimeters to measure the voltage the voltage servo driver sampled if we input voltage is 0 and enter the zero draft to these parameters P5-4, and then our system will automatic calibrate of zero draft inside the driver. And the second, this bias, it is means like this picture. It's easy to understand. And the last, the dead zone. And we can set this dead zone in P5-3 in this function code. For example, if we set this value as 1, then the input voltage between the range of if we set the dead zone as 1, as here the unit is MV, so if we set this value as 1000, then the input voltage between this range, our servo will get no torque instruction. This is how dead zone work. And last I will introduce some DI and DO settings of torque control. This is the torque mode rated DI function and DO functions. Our servo have 8 DI terminal and 4 DO terminal. For each terminal, we can set the channel function in these parameters. This one, and this one. For example, if I set this channel function selection as 1, means servo enable, and then when I use PLC to output a digital signal to servo to this terminal, the servo will become a RAN status. And also, if I set this channel function as 8, then when the PLC output a digital signal to terminal 1, the servo will stop. And here we also can set other function code, such as 3 means forward drawable prohibits, and 4 means reverse drawable prohibited. Okay. And here, for torque mode related DO functions, I want to introduce this one in details. Torque retreat. This function is used to output a digital signal when the servo arrange our setting torques. for example, and we need to set these two values, P5-20 and P5-21. And I will use a picture to show how these two parameters working. If we set P5-20 as 100% and set P5-21 as 10%, then when the actual torque is bigger than 110%, the torque ref single will output. And when the actual torque is smaller than 90%, the torque ref single will not output. And when the actual torque between this range, the torque ref single will not change. So also, for example, if we set our torque instruction as this 50%, and we set P5.20 as 80%, and set P5-21 as 10%. Then our range will be this one. It is 30% to 50%. So the range here, the range will become this one, and this is how these two parameters working. Okay, today's training is finished. Thank you for your watching.